Hello everyone, my name is Yusuf Jama.
Ahmed Ismail.
My name is Badrudin.
We're going to take you through a comprehensive analysis covering authentication and authorization in multi-user operating systems. We're going to talk about the mechanisms, threats, and the security models. Now onto the introduction part. The multi-user operating systems are designed to support multiple individuals and processes simultaneously, while also ensuring that each user interacts with the system's resources in an isolated and a controlled manner. Now, these systems allow shared accesses to files, applications, networks, and the hardware, therefore making security a very fundamental requirement. Now, to be able to maintain this proper separation between the users and prevent unauthorized actions, operating systems rely mainly on two main mechanisms, that is authorization and authentication. Now moving on to the authentication and authorizations, these are two distinct but very interconnected mechanisms forming the basis of operating system securities. Authentication basically tries to answer the question, who are you? By defining what authentication is, this is a process of being able to verify the identity of a user or a process. This involves different categories. For example, we can have passwords and pins, biometrics, cryptographic keys, and smart cards. Authorization, on the other hand, tries to answer the question, what can you do? The definition of authorization is determining the access rights after identity of the user is confirmed. These access rights involves file permissions like read and write, the access control lists, policy enforcements, roles, and also groups. Now, moving on to the background of the authentication and authorization, we're going to discuss about three. One, the principle of list privilege, user and group identification, and also the access control models. Now, starting with the principle of list privilege, this principle states that users and processes should be granted only the minimum level of access required to be able to perform their tasks. By limiting these privileges, the systems reduce the potential damage that can occur due to user mistakes, software vulnerabilities, or malicious behavior. On the user and group identifications, multi-user operating systems enforce authentication and authorization decisions using identifiers, group identifiers, and permission structures. A UID uniquely identifies each user, while GID classifies users into groups with shared permissions. Now, these permissions, such as read, write, and execute rights, are associated with files, processes, and system objectives to define how users and groups may interact with them. And now moving on to the access control models, we have different access control models such as DAC, MAC, RBAC, that provide the frameworks for managing how these permissions are assigned and enforced in operating systems, each with its strength and application. Now moving on to the core authentication methods, we have different methods. One, password authentications, multi-factor authentication, certificate-based authentication, and key-based authentication. Now moving on to the authorization models overview, we will talk about four of them in detail. One, the discretionary access control, the mandatory access control, role-based access control, and the capability-based control. Now starting with the discretionary access control, Linux implements DAC through the traditional Unix permission model, where each file has an owner group and permission bits specifying read, write, and execute rights. Now, DAC is discretionary because the resource owners here can modify permissions on objects they control at the discretion. While it's suitable for most use cases, DAC has limitations in high security environments, since authorized users can inadvertently leak sensitive information by changing permissions on files of their own. Now, for us to be able to mitigate this mandatory access control and to be able to mitigate the DAC limitations, mandatory access control comes in, which now establishes strict policies that govern access to the resources based on the security classifications. Now, MAC enforces system-wide security policies that cannot be overridden by individual users. Therefore, this approach confines the processes to minimum required permissions, preventing compromised applications from accessing resources outside the designated required domain. Now, moving on to the role-based access controls. The role-based access control tries to assign permissions to predefined roles rather than into individual users. A role represents a job function, such as a database administrator or regular user, and users acquire permissions by being assigned to roles. This simplifies authorization management, especially in large organizations, because permissions do not need to be repeatedly configured for each individual account. Instead, the system enforces access policies based on the user's active role in its associated privileges. And now moving on to the capability-based access controls. Capability system represents an alternative mode in which the processes receive what we call explicit tokens or capabilities that grant the authority to be able to perform specific operations on specific objects. A capability is unforgeable and acts as a secure reference with embedded permissions. Unlike ACLs, which store authorization roles with objects, capability systems now tend to store these authorization rights with subjects, which is the user or a process. Now this approach kind of like reduces the ambiguity in permission checks and supports secure delegations of privileges, since capabilities can be transferred under controlled conditions.
Now we're going to talk about the system implementation comparison between Linux, Windows, and mobile implementation, both for iOS and Android. When it comes to authentication and authorization for Linux, it uses a pluggable authentication modules, very flexible authentication methods. It utilizes discretionary access control for user-defined permissions and also mandatory capability-based mechanism. It uses all three. When it comes to Windows, Windows uses a centralized authentication and authorization through Active Directory, which includes both NTLM and Kerberos for security login. Let's define these two. The NTLM, which stands for New Technology LAN Manager. This is an old Microsoft authentication protocol which was used to verify and is still used now for Windows system loggings. This is the old system, and the Kerberos is a modern security authentication protocols. The difference between these two are this uses no tickets, challenge response authentication, which you sometimes see when you use Windows, and this uses a ticket issues key distribution, KDC. So yeah, these two both are used when it comes to Windows authentication and authorization. Alright, now we're going to move on to mobile implementation. Both iOS and Android use application sandboxing to isolate threads. Sandboxing literally means restricted movement with limited permissions, which means you can access files, specific files only, which you're granted access to, use control system resources. This basically means as much restricted environment as possible. These are what is used commonly when it comes to Android and iOS. Now we're going to move on to security threats and mitigation, or how to stop them. When it comes to security threats and mitigation, these are the 4 common attacks or security threats, and we're going to talk about each and how to mitigate it. Let's go through all 4. Number 1 is boot attacks. Number 2 is credential stuffing. Number 3 is privilege escalation, and number 4 is session hijacking. Number 1 is brute force attack, which is, as it says in the name, literally just uses brute force to systematically guess the password as many times as possible until you can get it in. And the way to stop this, the way to mitigate this, is to implement account logout policies, which is most of the time you see it on your phone login. You only have few times to try before it logs you out. This is how to stop the brute force attacks, by implementing a lockout policies to temporarily disable accounts after set amount of attempt failed. That's how you stop it. The second one is credential stuffing. Credential stuffing just means the reuse of passwords across different services. They can use a compromised password from other websites or other platforms or services, and they can try to use that password to access your information. To stop this is to use a multi-factor authentication, which means the password is not enough. Even if you get the password right, there's a multi-layered authentication. It makes you go through multiple checkpoints, and that's how you stop it. Number 3 is privilege escalation. Privilege escalation refers to exploiting flaws to gain a higher access. So you can use this to gain a higher access, which is not intended. To stop this, you use the principal least privilege, which is called POLP. This dictates the user should only have the minimum permission needed for task, not less, not more. Yeah, so it just gives you the minimum access required. And lastly, the session hijacking. This session hijacking involves stealing sessions tokens to impersonate a user with a proper authentication. A session hijacking literally just means jump into your already logged in session. To stop that, you can use HTTPS secured websites to minimize session hijacking, and those are different security threats and how to mitigate them.
The matching security frameworks, we have two sections: zero trust, continuous verification of access requests, and the passwordless authentication and eliminating traditional passwords. We're gonna continue to the second slide with the zero trust architecture. Zero trust changes how we think about security, and instead of trusting anything inside the network, every request must be verified. It uses strong authentication, least privileges, and macro segmentations with continuous monitoring. This makes it much harder for attackers to move around even if they get in. And to the next slide, the passwordless authentication. The passwordless authentication removes passwords completely. It uses biometric security keys or passkeys with standard like FIDO2. A device creates a cryptographic keys and the private key never leaves the device. This makes phishing and the credential theft much harder for the hackers. The platforms like Windows Hello or Apple Face ID and Android only support this passwordless authentication. And for the next slide, the conclusion and future directions. The authentication and authorization are the core security control that protects modern operating systems. Authentication confirms a user identity, while authorization determines what the user is allowed to do. Without this mechanism, attackers could access systems with weak credentials, or legitimate users could accidentally or intentionally exceed their permissions. Together, they ensure only the right people access the system and only within the limits defined for them. Operating systems strengthen this through layered design. Features like sandboxing, mandatory access controls, and fine-grained privilege capabilities that create multiple barriers that attackers must overcome. Controlled elevations tools help prevent unauthorized privilege escalations by building this protection into the system architecture. An operating system reduces the chance that a single failure results in a full compromise. The new approaches such as zero trust and the passwordless authentication, continuous behavioral monitoring are pushing security beyond traditional login-based modules. These methods remove implicit trust that replace weak passwords and validate any remote environment and adaptive context-aware security that will continue to grow in importance. The regular updates, audits, and user awareness remains essential to keep these protections effective.